In this video, we're going to be going over cation charges, and this is going to be our part 4 video inside of chemistry, chapter 2. And we're also going to talk about the stock system and also some practice questions to help understand more about this topic. So let's get started with this video. So first of all, let's cover over cation charges. So sometimes elements and atoms can form multiple and more than one cation. So this means that if we have an element, this element can have more than one cation. So for example, most of the transition metals from groups 3 to 12 on the periodic table contain more than one cation. So for example, there's copper, iron, these type of elements have more than one cation. And specifically in this video, we're going to look at why copper has different cations. So the first one is Cu+, and the second one is Cu2+. So we're going to see why copper has these two different cations, and that's the main focus of today's video. So let's get started and deep dive into why copper has these two different cations. So first thing that we're going to do is look at the electron configuration of copper. So once we learn about the electron configuration, then we can know why copper has these two different cations. So the electron configuration of copper, so first of all, copper is a transition metal with the atomic number of 29, and on the right here we can see there's a picture of copper, so we can use that as a reference as well. And the electron configuration of copper can also be written as this. So argon, and on top of argon we have 3d10 and 4s1. So the reason why we write argon is to keep it in short. Chemical formula for argon is 1s2, 2s2, then 2p6, 3s2, and 3p6. And then for copper, we just add on top of that, which is 3d10 and 4s1. So instead of writing all this together, all we do is we just take argon, and then on top of argon, we just write 3d10 and 4s1. And we get this from the table here on the bottom right. So from the table here, you can see that all of the different electron shells is over here, and that's where we actually get this configuration. So now that we know the electron configuration of copper, let's look at how we get those two different cations. So the loss of electrons. So forming cations, that means that you lose electrons. So since you lose an electron, there's going to be more protons than the electrons. That means we get a cation. So in this case, copper can lose either 1 or 2 electrons. So when copper loses one of its electrons, so that means one of its electrons is gone and given to some other element, then that means from the 4s shell it loses it and it becomes copper plus. So this means that it also has a stable electron configuration of argon 3d10. So this basically means the normal configuration of copper is 3d10 and 4s1 on top of argon. So 3d10 and 4s1 on top of argon is the normal configuration of copper. So that's what you can find. So when copper loses one of those electrons, so it gives it away, then it becomes argon and 3d10. So we don't have a 4s shell anymore. So we go from the basic argon 3d10 and 4s1, and then we get argon 3d10 instead. And alternatively, copper can also become copper 2+ by losing the 4s shell and also losing an electron from the 3d shell. And this forms copper 2+, and we write that in Roman numerals by copper and then 2. And this also has a configuration of argon and then 3d9. So in this case, the normal one for copper is 3d10 and then 4s1, so that's the normal configuration. And then if we lose one electron, then we get argon 3d10, and if we lose another one, then we get argon 3d9. So this is copper 2+, which is argon 3d9. So these are the two different cations that argon can form. So now we're going to talk about how both of these are actually stable, so how both of these two different cations are stable. So for copper +1, which is just copper +1, the ion is stabilized because there's a full orbital for the 3d shell. So instead of the 3d10, we have it's full, and if it's full, that means it's stable. So since it is full in the 10 shell, then there's going to be no more 4 electrons. So since there's no 4 electrons and 3d10 is full, that makes the copper +1 ion stable. And in the other case, for the copper +2, and this is also stable because the energy difference between the 4s and the 3s orbital is really small. So since it's really small, even if you remove an electron from the 4s and also one from the 3d, it's still energetically feasible. So that means even if you remove those, then it's still going to be stable. So this is how both the copper +1 and the copper +2 is still stable. And now we're going to talk about the stock notation. So the stock system is a method used inside of chemistry to specify the oxidation state of a cation when the element can have more than one possible charge. So if an element has more than one possible charge, such as we talked about copper, so if it has more than one, then we can use the stock system to show the difference between the two different cations or how many different ones you have. So for example, as we talked about copper, for copper, the +1 oxidation state, it's written as copper, and then in brackets we just write the Roman numeral. So since it's +1, we just write 1. So copper 1, and that represents the oxidation state of 1. And we know that the copper 1, if we have +1 in the oxidation state, then that means it represents the copper +1 ion. And if we had instead +2 oxidation, then we'll just write inside of the brackets in Roman numerals 2 I's, which represents 2. And another example that we can take is iron. So in iron, there's a +2 oxidation state, and then we can write that as iron, and then in the brackets we can write 2 of the I's, which represents 2. And this also represents the Fe2+ ion. So this is stock notation. So it's basically where if an element has multiple different cations, then you can represent it using this notation to show the difference between the two different cations that's there. And furthermore, the stock system is only used for metals that have more than one cation. So you do not need to write sodium 1 because sodium only forms one type of cation, which is Na+. But instead, for example, as we talked about copper, so since copper has two different cations, which is copper 1 and copper 2, that's why we write them differently using the stock notation. So the first one would be copper 1 in bracket and then the number 1 I, and then for copper 2 we just write 2 I's that represents copper 2+. So now we're going to go over some practice problems. So the first one here, we have write the formula of each of the following ionic compounds. So I'm only going to cover over the first one because everything else follows the same steps and formulas. So you can try all those out, and you might also need your periodic table to do this. So if you have that handy, that will also be good. So let's start off with the first one. So we need to basically just write the formula for each of these ionic compounds. So in order to do this, the first one we have cobalt, and then we have 2. So that means that it's a 2+ cobalt, and then we have chloride. So the first step is to actually look at the outer shell of chlorine. So if we look at the outer shell of chlorine, we can figure out how many chlorine atoms we need in order to satisfy this formula. So once we found out the outer shell, so first of all we need the atomic number for that. So the atomic number for chlorine is 17. So that means the outer shell valence electrons of chlorine is 7. So that means chlorine actually needs only 1 electron to gain the full outer shell. So since it needs 1 electron to gain the full outer shell, now we can look at cobalt and see what cobalt has to offer. So now if we look at cobalt's charge, we can see that it has 2. So that means the cobalt's charge is +2, which means it's giving away 2 electrons. So since it's giving away 2 electrons and chlorine needs 1 electron for the outer shell, if we put 2 different chlorine atoms together, then it's going to suit the formula. So if we have 2 different chlorine atoms, then those cobalt, since it's giving away 2 electrons, then chlorine will grab them, and then that will make the formula CoCl2. So if you look at the solution, we have cobalt chloride, and then we have CoCl2. So this is how you can actually find out the formula for all these different ionic compounds, and the rest of them for B, C, and D, they all follow the same steps and formula, so you can try that out yourself. So now for the next practice problem, we have to determine which cation is in each of the following compounds. Then we need to write the name of the compound using the stock system. So all we're going to do is just write the compound in the stock system form. So once again, I'm only going to cover over the first one, and you can try the rest of them out yourself. And you might also need your periodic table for this one as well. So let's start off with the first one, which is SnO2. So SnO2, first of all, we need to know what the elements actually are. So Sn represents tin, and O is obviously oxygen. So in this case, we need to write it in the stock system formula. So since there's 2 different oxygen atoms, if we combine those two, the outer shells, then we're going to have 4 different electrons that we need from tin. So that means that tin has to have a charge of +4. So since tin has a charge of +4, that means that our formula is going to be equal to tin. So inside of the brackets, we're going to write the Roman numerals, and then which is just going to be IV, and so it's going to be tin IV oxide. So that gives us the formula inside of the stock system. So it's just going to be tin IV and then oxide. So this is the solution. We can see that we have tin and then we have IV and oxide. So this is how we can actually get into the stock system by finding out from the formula. And feel free to try the rest of these problems out by yourself. So that summarizes all these practice problems that we've done, and that's also a summary for this video. So let's just go over a quick summary to see what we have learned. So first of all, we talked about cation charges, and second, we talked about the stock system, and third, we also talked about electron configuration. And we mainly took the example of copper in this case, just so that we can get a better understanding about these different topics that we learned about. And in our upcoming content, we're going to do some more practice problems for ionic compounds, and we're going to see what we can do from there. So that summarizes everything from this video. So thank you so much for watching from Try to Be Useful, and we'll see you guys in our next chemistry video.